Hi, I'm Shiraj, and here I'm presenting my project for the gold points portion of Project Zero for the CS61B class at UC Berkeley. So the original project was a Java-based simulator which allowed you to simulate the physics involving multiple bodies orbiting around each other in space. And so we started with the Sun, Venus, Mercury, Earth, and Mars. And so in the original simulation, we had an initial position for them, we had masses assigned to them, and running the simulation, we were able to see a simple orbit of them, all the planets moving around the sun. Now, for the gold points project, the way I extended this original project was to first port it so that it runs in the browser, and second, add some interactive features to modify the masses of these planets so we can see what would happen if these bodies had different masses than what was initially assigned to them. First of all, I ported this application to the web. And so in order to do that, I converted all of the code for the original project to the Scala programming language. So the Scala programming language is very similar to Java. By default, it compiles to Java bytecode, which means it can run in the JVM, which is where Java code runs. And so it can use Java libraries, and you can use it with Java frameworks. Now, the cool thing with Scala is, in addition to supporting Java, recently Scala has gained support for many other platforms. So in this project, I used a tool called scala.js. So scala.js is a Scala to JavaScript compiler. And so what this lets you do is you write your code in Scala, but then instead of compiling to Java bytecode, you compile to JavaScript code, which can run in the browser. Similarly, there's another project called Scala Native, which I've been involved with, and that is a Scala to LLVM compiler, which allows you to compile Scala directly to machine code and run it on embedded devices, such as for robotics applications. But in this project, I use Scala.js. In addition, to implement the web interface, I used the React.js library, which is a framework developed by Facebook for creating interactive websites. Now, React.js is normally used with JavaScript code, and so to use React with Scala, I used one of the libraries that I've created in the past, Slinky, and Slinky is a framework for writing applications in React with Scala.js, and so it lets you use the concepts from React and use the React library, but it provides an interface that lets you keep your code type safe and allows you to use idiomatic Scala patterns to implement your components and the user interfaces in your project. Now, in addition to these tools, one of the interesting things about the web is you don't have swing on the web. You instead have what's called the Html5 Canvas. So the Html5 Canvas is what's being rendered in this portion where you have this universe backdrop and all the planets. And so it gives you a very simpler interface to say, I want to draw rectangles, I want to draw images, to specific coordinates on this canvas. It's pretty similar to Swing for its API, but it is a separate API. And so to interface it, you can either directly use the Canvas API, or for this project, I used a library called Conva, which allows you to declaratively specify where you want different images and shapes to be positioned on the canvas. And Conva handles the process of deciding what layer should be where and how to best use the Canvas APIs to efficiently render all of this information to the canvas. Because Conva is set up in this declarative way, it works really well with React, where in React you specify, I want these HTML objects to be rendered with this contents, and so similarly, there's a library called React Conva, which allows you to, in addition to rendering HTML content from React, you can also render to the canvas in a similar style, specifying, I want an image to be located at this position, I want my backdrop to be spread across the canvas. And so to use this library, I also developed Facade, which allows you to use this Conva library from Scala.js. Because Conva is a JavaScript library, it's dynamically typed, but in Scala we want everything to be statically typed. Since Scala is like Java, it's a statically typed language. This Facade allows us to interface to this Conva library without losing that type safety, with manually defined types for the APIs. So once we have all of this set up, we get this application, so I can reload the page. We see the simulation, and this is showing the same visuals as the original Java-based project, but now everything is running in a browser. So this is running in Chrome. Now, for a couple additional features added. So first we have simulation time. This is generated based on the current time tracked in the universe, and then we're able to split it up across years. So for example, we can see that here the Earth started out, and so when the Earth comes all the way around, you'll see that the years goes to 1. So we're tracking the years that have, a number of years that have occurred in this universe simulation. Now that we're on the web, we want to make things interactive. And so what I added to this project was the ability to modify while the simulation is running live, the masses of these different objects, which allows us to see some fun effects to imagine what if different planets had a greater mass or smaller mass. So for example, what if Mercury had a larger mass? So Mercury is right here in the middle. And so if I increase the mass of Mercury, this is on a logarithmic scale. So a small increase actually corresponds to a small move on the slider corresponds to a very large increase in the mass. And so as I continue to increase it, you'll start to see the sun to wobble. You'll see the sun starts to wobble. Yeah, so there we see the sun is wobbling a little bit. And this is just showing that all the physics are running live. And so as Mercury's mass increases, it has a larger effect. And so it's not just the sun that's pulling Mercury to spin around it anymore. Mercury is also having a pretty large effect on the sun. Similarly, we can see, what if the sun had a larger mass? So if it had a larger mass, you see kind of the slingshot effect as they come very close to the sun. And similarly, if we reduce the mass, we see that the planets drift off because now the force isn't enough to keep them in their orbits. And so with this, you're able to play around, understand how the masses of these different planets affect all their orbits. And so it's fun to play around with this. So that's what I developed for this Gold project, the ability to run this entire application in the web browser and have your graphics rendered smoothly to a canvas, and this interactive portion, which allows you to move around these sliders and experiment with different properties for all these bodies.